Hmm. Last class we were discussed about system regions, like regions of operations or scheduling schematics. What are the regions are there in our Verilog active region, and then in active region what are the statements are executing, like blocking assignments are executing, and RHS should be evaluated, continuous assignment should be evaluated, dollar display statements are also evaluated here only. And then inactive region, hash zero statements will be executed here. To avoid the race conditions, we will consider this one. Okay. And then NBA region, whatever the RHS updated in the active region, so here LHS should be updated. Okay, so our output should be updated here NBA region. And then so why blocking is dangerous in our sequential logic means, so blocking will be executed immediately, right? So whenever the input is given, output should be obtained at the same time only. So NBA reason, to solve this problem, to avoid the race conditions in that always begin block. Okay, so always begin block, don't use that blocking statements. Always we need to utilize that non-blocking statements, then only this race condition will be avoided. Okay. And then monitor region, just dollar monitor, dollar strobe is there. So dollar monitor continuously stores the values, and then dollar strobe, which will last updated value only it is checking that. Okay, so whatever the last updated value is there, that will be considered in the dollar monitor region. Just give me a minute. Okay, this is complete. What are the statements are there, where exactly it is executing? Hash zero non-blocking, that means hash delays are there, means that will be executed in the future region. Okay. And then what else here, non-blocking statements will be executed immediately. Okay, so active region only it is executing. And then non-blocking RHS is evaluated in the active region, and then LHS will be updated in the NBA region. Okay, so these are the times where it is executed exactly, because in our Verilog regions why we need means, in Verilog all the data are executed parallelly. So that's why these regions are important to execute. Which one is executing first, which one is executing last, that we will know. Okay, so these are the regions and summary. After that, system tasks in Verilog. What are the system tasks are there in Verilog? Okay, system task in Verilog is used for generally displaying messages. Okay, so it performs like a displaying messages. Whatever the display messages are we are having, that should be displayed here. Okay, so every symbol, there is a keyword like dollar is there. Okay, so dollar display we are using, dollar monitor we are using, a dollar write we are using, dollar strobe we are using. Okay, anything we are utilizing that. So before that, we are adding dollar symbol for the each terminal. Okay, and then different formats are also there. I will explain each and everything here. Okay, see what are the system tasks. Okay, system tasks are usually predefined simulator commands. Okay, so why the predefined simulator commands means, we are printing the messages. Sorry, we are printing the messages, and then monitoring the signals, whatever the signals we are having. Okay, those signals we are continuously monitoring, and then controlling the simulation, like who is executing first, who is executing next, that will be controlling the simulations. generating the randomness means different values we will get. Okay, so all these are helpful in our debugging time, printing time, monitoring signals, and controlling simulation. All these times we will use these system tasks and functions. Okay, so both are same. And then examples, what are these? Dollar display, dollar monitor, dollar finish, dollar random. Dollar display, wherever the updated value we are added this dollar display means those values only displayed at the output side. Suppose a equal to 0, b equal to 1, I have given my stimulus. Then we are writing the dollar display statement here. A equal to percentile 0 b, b equal to percentile 0 b, a comma b. For this instance only these values will be printed. That is the use of dollar display. Okay, so and dollar monitor we are writing means same thing. I am utilizing the dollar monitor. A equal to percentile 0 b, comma b equal to percentile 0 b, comma a comma b. I have utilized that. Okay, just these are the stimulus values. I am separating that display values, and then simulating values I am separating that. Okay, whatever the double quotations inside that double quotations are there, so that is related to string type. If you write anything in this double quotations, that will be appeared at the output side. Okay, so that is the reason we are writing here. And then here what it is, the meaning of dollar monitor means a equal to 0, b equal to 1. This is also appeared at the output side. And then hash 10, a equal to 1, b equal to 0, this value also we will display. And then hash 10, a equal to 0, b equal to 1, this value also we will get. Just write the single dollar monitor statement, we will get all these values, because this dollar monitor, whenever input is changes, that will captured and displayed at the output side. Clear? Any doubt in this? Okay. See, so dollar display system task, what is that? These tasks prints the information. Whatever the information we are having, that will be printing. So dollar display immediately printing. So a equal to 0, b equal to 0, that will be printing immediately. And what is the difference between the dollar write and dollar display means? So this dollar write not automatically taking the new line. So this dollar display, every time wherever you are writing, it will be displayed in the new line. Okay, the first line a equal to 0, b equal to 1, we got the output display here. And then you are writing another display statement a equal to 1, b equal to 0. So this will be taking in the new line of the next simulation. Okay, so but dollar write is not like that. So a equal to 0 comma b equal to 1, this is one simulation. And a equal to 1, b equal to 0, so this is second simulation. It is hard to identify who is first and who is next. Okay, because it is not taking the new line automatically. We need to write new line slash n. Okay, lexical tokens time, I will explain, I have explained this one. Slash n slash t slash what it called, slash t means tab, slash n slash s, some spaces. Okay, so slash n means new line will be taking place, not the forward slash backward slash, this one. And then dollar monitor continuously monitor the values. Okay, wherever the changes we have, that will be continuously monitor that. And dollar strobe, what is the last updated value? See, a equal to 0, b equal to 1, a equal to 1, b equal to 0, a equal to 0, b equal to 1, and a equal to 1, b equal to 1. This is my last updated value. This one only printing at the output side. Okay, so this one only printing at the output side, that is the dollar strobe, print at the end of time slot. So end of time slot means wherever you ended your simulation, before that whatever the stimulus are there, that will be displayed at the output side. They will ask you dollar display what it is doing, dollar write what it is doing, dollar monitor what it is doing, and dollar strobe what is the use, all these things. See, dollar display, dollar write is also similar to dollar display only. But what is the main difference here? Dollar display is taking every time new line. Okay, every time new line will be taking every time. But dollar monitor not considering new line. Okay, not taking new line. That is the main difference here. Both are same. Okay, dollar monitor and dollar write, sorry, dollar display and dollar write both are same. Okay, so dollar write does not add new line automatically. That is the problem. See, this one we will write that, and this one we will write that. Okay, dollar write a equal to some quotations or percentage 0 to a. We will write that. And dollar monitor, it's a debugging tool. Okay, debugging tool. Why I'm saying that, it continuously, automatically, and continuously printing that values. Okay, so continuous watches the signals. Whenever signal changes, it automatically print that. So that is the main thing. So continuously watching the signals, A equal to 0, B equal to 1. So this changes happen, and A equal to 5. Next B equal to 10. This one change also happen. Whenever the changes happens in the stimulus tide, okay, this dollar monitor will capture the values. Okay, any doubt? Dollar monitor, dollar write, dollar stroke, dollar display. Okay, and then some common specifiers like percentage 0b, percentage 0d we are using, right? So this percentage 0d you are utilizing at the display side means that will be printing the decimal values, like a equal to 5 you are mentioning that, b equal to 10 we are mentioning that. So in dollar display we are writing that format like this, like percentile a equal to percentile 0d, and then b equal to percentile 0 uh, b. In this format we are writing this percentile 0b. Why we are taking this percentile 0 means, so suppose I'm taking 16-bit number. Okay, my variable size is 16-bit, that means 15 down to 0. Okay, so then I'm assigning that 16 tick some hexadecimal a only I'm assigned, and then remaining 8 bits I'm not assigned. That means zeros will take that 00 AA. Okay, so if you are not using percentile 0d or percentile 0h or percentile 0b, okay, here 8 values only we are giving, remaining 8 values are 8 bits are not given. Then your display, if you are not using percentile 0d, your display will like this. Okay, a will be printing, and there is a space here. Okay, that space we are not getting at the output side by using this percentile 0d. Okay, that means specific formatter before that we are using that 0 means that will remove the space. Okay, if you are not using the space means, so 0 means percentile d only we are using, then a only printing, and then the space is there. Okay, this space will be there. Okay, clear? That is the basic difference, percentile 0d or percentile d. Okay, so 0, yeah, 0 why we are utilizing means the 0 will places that some, if you consider the display statement, just see any display statement. Okay, so write the code, and then without using this percentile 0 d b all these things. Okay, yeah, tell me. Only space only. So not taking any other values, because we are not assigning any value. that will not considered any value. Okay, so just space only it is taking, because the capability of storing variable is 16-bit, but you are assigning 8-bit only. Okay, so the remaining 8 bits will be taking as a space. Okay, that is the format. Up to this basic number system formats only. Percentile 0D means, sorry, percentile C means any characters you want to print. That means single character I want to print. C I want to print. And then D I want to print. Or B I want to print. Or A I want to print. Okay. So for single character you want to print means percentile C, we will consider that. And percentile S means string name. Okay, some hello VLSI. Okay, this string I want to print that. So then percentile 0s I need to consider that. And then percentile T is used for current simulation time. What is the current simulation time? Dollar time we have, right? So this dollar time we are printing like this percentile T. Whatever the time we are having, that will be printed in the output side. And percentile F means real numbers like 2.5, 3.7. Okay, so any floating values are there means, so that will be printed by using percentile F. Okay. So these are the simulation control tasks. Okay, dollar stop is stopping the simulation. Just pause the simulation, not ending the simulation. So just dollar stop we are using means that will pause the simulation. Like we are watching some video. Okay, you are watching video. So you are just got a call. During that video will be paused, right? So pause the video, that is the purpose dollar stop we are using. Otherwise dollar finish we are utilizing means it terminates that, ends the simulation completely, and it terminates the simulation. Dollar finish we are using means this finish will terminate that. Okay, okay, terminate the simulation. There is no stopping, just ending the simulation. Okay, this dollar stop will stop that. Anyway, if you want to resume the video from that position only, you are displaying that. But here not like that. So where we are using means debugging purpose, and then any waveforms you want to inspect, at that time we will use this dollar stop signal. Okay, so dollar finish means it finishes the simulation terminated. Okay, there is no any existence here. Okay, just dollar stop means pass the simulation, finish means exit. Directly it will exit from the simulation. There is no further execution of your uh, simulation, right? And then dollar monitor, sorry, dollar random. This dollar random, sometimes I want to generate some random values here. Okay, those random values means, suppose I'm taking some dollar random. So range I'm mentioning that 0 to 100. Okay, so this is the minimum value, this is the maximum value. Okay, in between that any numbers I will get that. So suppose you are using this dollar random means generate pseudo random values. Like suppose you are assigning a value that is equals to dollar random. This random value, suppose a has some width. The width is having some 3 down to 0. 3 down to 0 means 2 power 4, like 2 power 16. So 2 power 4 means 16 values we will get. Okay, A is capable to store 16 values. So then here A equal to 0 will get, or A equal to 5 will receive, or A equal to 11 will receive, or A equal to some 14 which will store. Okay, randomly it is taking the values, not manually. So manually we are not randomizing any value. If you are considering this dollar random means that dollar random will consider different values. Okay, so see, I will consider different values depends upon the range. Suppose I am considering 7 down to 0 of a, then 2 power 8, so it is capable to produce 256 values. That means this variable a is capable to store up to 0 to 255 values. Then it will generate that between the 0 to 255 values. Whenever uh, you want to debug your simulation, at that time this dollar random it is taken, because we are we are generating the test cases. At that time, manually you are assigning some values, some a equal to 5, a equal to 10, you are assigning manually. That will be passing the test cases. Okay, no problem. But manually it is passing. If you check that random values, so have you given any random values, they will ask you at that time. Okay, so you need to give some random test cases. Okay, because this UVM is automatically randomize the variables. Okay, so that is the reason. Some random keyword, while explain the SV, I will explain this. Okay, why we are using rand keyword. Okay, what is the reason for that? Okay, so we will randomize the values. So these are the summary. Why we are using this system task in Verilog means it's a predefined simulation command. Okay, so just for controlling the simulation flow. So that is the reason we are considering this system task, all these things, debugging purpose, monitoring purpose, controlling the simulation flow, all these things we are using this system task. And then tasks such as dollar display, dollar write, dollar monitor, dollar monitor, and then dollar stop, all these things we are using, right? This dollar display, dollar write, it is executing the active region. So remember that. So whenever you're writing dollar display, dollar write, both are same, right? So that means whenever you want to execute these dollar write, dollar stroke, dollar write, and dollar display, it will be executed in the active region only. Okay, remember that. And then continuously monitoring that, right? So dollar monitor, so this will be executed in the dollar strobe and dollar monitor. I will so it will be executed in the NBA region maybe. So the monitor region is a just postpone region we are using, that dollar monitor and dollar strobe. So we are displaying at the uh, what it called uh, monitor region is there, right? Postpone region. At that time this dollar monitor and then dollar strobe will be executed. Okay, suppose I have explained you some a equal to 5 and a less than equal to 7 is there. This will be executed in the active region, right? And 7 will be executed in the um, active region only. Okay, but a is updated at NBA region. Okay, if I want to display this value here only, then I will use this dollar strobe. Okay, dollar strobe I have utilized means that will be getting the updated value, last updated value. What is the last updated value here? A equal to 7, that will be displayed by using the dollar strobe. Okay, that means it is telling that final stable value of final stable values at the end of the current time slot. Whenever the last time unit is there, that will be updated here. So then I will get 7 also in my display. Okay, and dollar stop, I told you just pass the simulation, just suspend the simulation. So pass the simulation, and then if you want to again if you want to again visit that video, then you will resume that video. And then so simulation also we will resume that simulation. And then dollar stop means so it completely terminates the simulation. There is no mercy here. Dollar random is so it generates that random numbers. Okay, so they will ask you without rand key how can we generate the random numbers means dollar random you can use that. Okay, this dollar random generating the random numbers. So these are the compiler directives. Any doubts up to this? Dollar monitor, dollar strobe, dollar display, dollar stop, dollar finish. Oh, so then compiler directives. What is the use of compiler directives? Okay, so suppose I want to execute some numbers or something. So I want to include some other file in my main file. Okay, so or I want to check that condition is executing properly or not. Okay, so for that purpose, these compiler directives are utilizing that. Okay, compiler directives are like instructions to Verilog compiler. Okay, so it will not in the part of simulation, just for controlling the purpose only we are using this one. Okay, so different compiler directives we are having some tick define, tick include, tick if define else, all these things. Okay, so sometimes I'm utilizing some parameters. I want to override that. So then define files I want to write that. And then timescale unit. Suppose my timescale unit 1 unit by 1 nanosecond it is taking. That means unit time precision value both are equal means so same simulation time I will receive that. Okay, all these things we will explain here. Okay, I told you compiler directives are special instructions to give the compiler before simulation start. Whenever you want to start the simulation, so at that time these compiler directives will take place. Like tick define. So the keyword is called tick. Okay, this tick will before the variable we will mention tick define. Okay, it defines all the variables. Okay, whatever the variables we are having, all the variables it will be displaying that. So compiler directives after compilation, it is not in the hardware logic. Okay, do not execute during the simulation. Just for compilation time only, it is taking that because sometimes I am utilizing some parameters. Okay, so these parameters, whatever the parameters I'm utilizing, some width I'm utilizing, ADDR width, some address width I'm utilizing, or address depth I'm using. Okay, so these address width and depth we are utilizing in different variables. At that time, this compiler directives will replace that. Just tick defines variables, it will be taking that, and then whatever the widths or parameters you are utilizing, that will create a separate file. Okay, that is the reason it is not involved in the simulation time. It is during in the compilation time only. That compilation time means it will check all the syntax errors. Okay, any syntax errors are there, that will be taken care by this compiler directives. At that time only it is involving. It is not involved in the hardware design like we are designing this hardware. Okay, and gate or gate and some other and gate. Okay, so these two are connecting to another or gate. Okay, so this hardware designing purpose, it is not involved. It is not involved. These compiler directives are not involved in the hardware logic. So it is available in the compilation time only, and it is also not available in the simulation time. Okay, so simulation means it will check the functionality. Okay, so what are the functionality we are writing, that functionality will check in the simulation time. And then compilation means syntax errors. If you are written any syntax errors, it will take care of that. Okay, so during the compilation, so first compilation is done, after that it will move to the simulation. See, tick define. What is the use of that? I will explain that. Tick define, tick include, tick if define, tick timescale. What is the use of that? Okay. So these are main directives. Tick define means create the macros. Okay, whatever the macros we are having, that will create that. That means some parameters we are utilizing, that will be creating here. Okay, defines file, it will decide that. And tick include is that I have one file in one place. Okay, that file I want to include in my main module. So at that time, tick include we will use that. Tick if define. Okay, tick if define means that is a conditional compilation. That means if condition is true, a greater than b, so this condition is true, it will take that dollar display statement. Otherwise it will take that another alternative path, right? So whenever we are writing something, okay, that will be conditional branch we are writing, right? That will be executed with this tick define. Tick not defined, that means if it is opposite to that conditional, so if you are not defined, then it is executing. End if, else if condition, tick else alternative condition, and then end if means whatever the simulation we are having, that will be ending. And tick timescale. Tick timescale, it is used for simulation time. Okay, whatever the simulation time we are having, suppose I'm utilizing like this tick time scale 10 nanoseconds by 10 picoseconds, or 1 nanosecond by 10 picoseconds. In this way we will utilize that, or sometimes 1 nanosecond by 1 picosecond. Tick time scale, for each and every one there is a separate rule. I will explain in the further slides. Okay, see what are the see why we are using this compiler directives means we will reuse entire code. Okay, so whenever you are utilizing these tick define files and then tick include files, we will reuse the code. Okay, and also some debugging options also we will have. Okay, it helps to create that reusable code and configurable RTL, portable designs, and then simulation control purpose. All these things we are using these compiler directives. Okay, see macros means what? Some text formats we will write. Tick define macros definition, right? So this creates some text substitution, like just it will substitute some values. Okay, some width we are taking or depth we are taking, that text will be substitute here. See, tick define width. Okay, so this width is that 8 values, it will be storing that. Now, so compiler replace this width is 8. So everywhere, suppose I want to change this width is equals to 16. Here only I will change that, and don't go to each and every variable. Suppose I'm taking this variable. This width is having some 8 bit. Okay, that means 7 down to 0, and then B also having some 7 down to 0, but I want to change this 7 down to 0 to 8 bit to 16 bit. Again I want to go for here, okay, some A and then 15 down to 0, and B, that will be 15 down to 0. In this way I want to change, okay, some 15 down to 0 of A, okay, comma some 15 down to 0 of B. In this way each and every variable I need to go there and change accordingly. But this tick define is not like that. Just it is replacing that width wherever you are using the width. So that will defines with the tick define width. So then you are changing this value 16 to 32. Your 32 to 64, 64 to 128. And don't go anywhere. Here only you can change, and it is applicable to all the variables you are utilizing in your code. Okay, clear? Tick define is a macros definition. See, just I am utilizing this width. Okay, see, tick width. I am using that. So this tick width. So generally, what it is having, this range I am having. Okay, this reach some data 7 down to 0 data. This is manually we will write. But by using compiler directives, I am using that tick width minus 1 down to 0 because I have already defined that tick define some width, okay, or tick define some depth. I have mentioned already here. So width is my width is 8 and depth is 16 here. Okay, so then each and every variable it is looking that wherever you are using this width and depth, that will be changing automatically. Okay, that's what here explained. Tick width minus 1 down to 0 data. Okay, then width you are considering 8, then compiler is taking like this 7 down to 0 of data. That means this data is capable to store 8 bit width. Okay, 8 bit means 2 power 8. 2 power 8 means 256. Up to 0 to 255 values it will be stored. Okay, see, these macros will be replacing just a simple text, not the function. Okay, so just replacing the tick width, it is replacing that, or tick depth, it is replacing that, or tick address width, it is address width, it is replacing that. Okay, or tick address depth, okay, some address depth, it is replacing that. Okay, so in this way the text only it is replacing that. Okay, that is the main thing. If you want to change easily, it can configure that entire design will be configured to 16. See, I want to change my width here, so some tick defined width equal to 16 bit I am applying here. So then whenever you are utilizing the variables like this, suppose a is there and then tick width minus 1 down to 0 and then so b is there, some tick width minus 1 down to 0 b and then c is there and tick width minus 1 down to 0 is there. So each and every variable is considered is applied this 16 width. So because you are changing this width is to 8 to 16. Previously 8 is there, that should be changed to 16. Then each variable will be treating like a 15 down to 0 of A, B, C. So this compiler will takes like this. Okay. Any doubt in this? Minus 1 down to 0. I didn't get that. Just can you repeat again? Yeah, yeah. Tick with minus 1 down to 0. Yeah. Hmm. No, in your module, you are taking, suppose my module is there. Okay, so some half adder you are mentioned. So this half adder is taking nothing, right? Some memory controller I mentioned that. Okay, so then I want to represent some ports list, right? So the ports list, some input I mentioned that input. What is the variable? Y and then data I have mentioned. Okay, and then input wire address I mentioned. Okay, so input wire some right pointer I mentioned that. Okay, so this width and address having some depth, like some widths are there. Okay, so like this data is there. Okay, this data is having some width like this, 7 down to 0. It manually I will represent here. Okay, so then I want to make this module to parameterized module. So the parameterized module will create like this. See, I will create this module uh, hash some parameters. We will use that parameter, some hash parameter width. I will mention that width. I will mention that 8, and then depth. I will mention that 8. Okay, so suppose one reference memory you are utilizing. This is my reference memory. In this reference memory you are utilizing this depth. Okay, depth minus uh, depth minus 1 down to 0. Why I'm taking this depth minus 1 down to 0? Because it is starting from 8, right? So 8 minus 1 down to 0. So that means 7 down to 0. 7 down to 0 means 8 bits will be considered, right? That is your doubt or any other? Uh, uh, yeah. Hmm. Sup. Yeah, yeah. So you suppose this depth you are changing to 16. 16 bit you want to change that. Then again this 16 minus 1 down to 0. That means 15 down to 0. This 15 down to 0 means 16 bit, right? Yeah. Okay. So what is the purpose of tick include? We are using that. So this tick include will add the file. Okay, we'll copy the file, whatever the content in the other file. Okay, that will be added here. Okay, so that will be inserting here by using tick defines dot sv dot v. Okay, tick include dot v. Suppose I am utilizing some other variable, some other module that will be included here. Okay, tick include defines.v. Suppose I am utilizing this defines. Okay, this defines files I am using that. This defines I am utilizing different parameters. Parameter 1, parameter 2, and then parameter 3. Different parameters are there. All these parameters I am also utilizing in the another module. Then I don't want to write again another defines file. Just I will include this defines file in my current module by using this tick include defines.v. Okay, so any other module you are utilizing again, so reusing again. So by using this inserting the comment, so it will be utilizing reuse. Okay, it will be utilized. That means we will reuse the module again here. Okay, meaning that this compiler copies the content of defines.v into current file. Okay, so what is this meaning? It include defines.v. It will include whatever the content available in this defines.v file. Okay, that will be copied and applied in my current module. Clear? What is the use of tick include here? So that means reusability will be improved. That I don't want to write again with files and then depth, all these things. I don't want to rewrite again. Just already written in one file that will add here. Okay, that will add here. Then it is utilizing that include file here also. Okay, that will add here and then it is also included. See why it is important that see parameters we are using that and macros I am using that and all these things are we are writing every time, so that would be the problem. So for that reason I am utilizing these include files. so it will be reusable the files, whatever the files we are having. Okay, so that will be reutilized. Okay, see, conditional compilation like tick if defined. So tick if defined is that when we are using that in compilation time, if the condition is true, then only it is going there. Okay, see, tick if defined and operation. So some and operation I'm utilizing that. So anywhere and operation is there, it will consider this one. Or operation you are utilizing, okay, it will go that. So then tick define and operation or operation I'm utilizing means, so and operation it is doing that, it is correct, then no alternate path it is choosing that. Okay, if it is not correct, then alternate path it will be choosing that. Okay, sometimes I'm utilizing many if conditions, that if conditions I want to reutilize in some other modules. At that time this will be useful. Okay, so tick if define, it is operating any operation. Suppose I want to execute this tick if define some multiplexer operation, mux operation. This mux operation is true, so then assign what it is called, assign some output equal to, we will assign like this. Okay, some select line. Okay, it is true. Okay, so then I1 will be getting that. If it is false, I2 will be getting at the output side. Okay, so this if defined mux operation is going for this condition, or tick else condition. This else condition, what it is doing that, some encoder operation or demux operation it is doing that, some or operation it is going to that, then assign out equal to I1 XOR with I2 it is going to operate. That means if you are going the true condition, I want to execute this mux operation. If it is false, I want to execute this XOR operation. Okay, every time it is needed means, so I will reutilize by using this tick defect time. And then tick end if means it is ending the conditional operation, and if it is ending the conditional operation. So why it is unselected code for completely ignored? See what it is that meaning. Suppose tick if define is not there means that complete code will be ignored during the compilation time. Okay. Suppose you are not assigning this if define. Okay, tick if define. You are assigning that some condition is checking. Suppose this condition is not assigned to this, and then this condition is not executed in my compilation time. Okay, why we use this one? So again, debugging modes and then simulation operation. Some specific codes you want to execute it, then we go for this conditional if define. Okay. So else and end tick else means alternate branch, right? Else condition you are taking means alternate branch, and end if we are considering means that is the ending of your block. Okay, see what it is doing, that tick if define debug. Okay, that debug will be displayed at the output side. Again, else condition, it's normal operation. It is taking that. Clear? Any doubt in this tick if define? So this if define is mentioned, some debug operation. Anywhere debug is there, it will be displayed here. Otherwise, it takes the other part like normal operation. It is taking there. Okay. So I will explain the examples. Then we will get that one idea. Okay. So where it is used at exactly. Okay. See. So tick undefined, that means not defined. Tick not defined. See, tick defined, tick if not and tick if not defined width. So this width is not taking, like whatever the defined statement you are considering, this will be absent. Only width only is absent, means that defines width only if it is absent. Okay, if it is condition is there, okay, tick and define width is there, at that place this width will be absent. Okay, we are not considered that width because tick and define we are taking that. If you don't want that width, then go for this width value. So if you want that tick if define, you can use that tick if define. If you use that tick if define, then this width also applicable at that place. If you are writing tick if not defined, then this width is not applicable to that variable. Okay, suppose some tick if defined, uh, I'm utilizing condition like and operation a and b. Some and operation I'm utilizing that this a and b are having some widths. Okay, so some widths are having width 1 minus 1 down to 0, and b is also having width minus 1 down to 0 is there. Okay, so these widths are not considered when if you are assigning that tick if not defined. Okay, tick if not defined, you assign means at this condition this width will be absent. Okay, that width is not considered anymore in the further conditions while using that condition. If you are using that condition, then further conditions will not be executed. Clear? See, tick time scale. What is the use of this tick time scale utilization? Simulation time unit is mentioned. This is the time unit and this is the precision. Sorry. This precision means the floating values. Okay, some floating values we will get that. 1 nanosecond by 1 picosecond. Usually we will consider this. Any simulation tick time scale 1 nanosecond by 1 picosecond, we will usually consider that. So that means whatever the time unit we are having, suppose hash 10 you are taking, that will be exactly we will consider that. Sometimes 110 nanosecond by 1 picosecond we will consider that. 100 nanosecond by 1 picosecond we will consider that. Sometimes 1 nanosecond by 10 picoseconds we will consider that, or 1 nanosecond by 100 picoseconds we will consider that. So in this way also we will consider different time scale directives. Okay. Any doubt in this tick time scale? See, this time unit, what is the meaning that? All delays are interrupted by using nanoseconds. Okay, and picosecond means smallest at the simulation and resolution. Simulator resolution purpose, we are using this picoseconds. That is the precision values. Okay, clear? Any doubt for this up to now? This compiler directives, some tick define, if did not define, all these things, macros. Okay, so just go through that and then you will get an idea. So once we will write some course pins where you are utilizing these macros or compiler directives, you will clearly know that each and everything. Okay, see what is this meaning? So example hash 5 is there, right? I told you hash 5 and then tick time scale 1 nanosecond by 1 picosecond. So every time 5 nanoseconds delay it will be considered that. Suppose hash 10 you are considering that. So hash 10 a equal to 0, b equal to 1, and then hash 10 you are considering. That means wherever you are utilizing these delays, that much delay only it is applicable. Okay, see, whenever you are not utilizing this time scale, then your test bench debugs at different intervals of time. Okay, it will not follow some particular time. That is the reason. See, without correct time scale, delays becomes inaccurate, right? Then test bench mismatch occur. then timing debugs will be appear, right? So then I don't know where it is executing exactly. So this tick time scale is not there means your simulation will be executing some other where. Okay, so some other time exactly I want to execute my output 10 seconds delay. Okay, 10 simulation time minutes delay. At this time I want to execute my output some C or D, A equal to C or D. I want to execute it, but it is not executing because this time scale is not mentioned here. Okay, and delays are not mentioned properly, then it will execute different intervals of time. Okay, see precision value, I told you right, round off value it will be considered that suppose 1.0 1.5 it is taking means, so this 1 nanosecond by 1 nanosecond by 1 nanosecond, so actually 1 nanosecond by 1 picosecond I think we will consider. This is precision value. 1 nanosecond means values are smaller than 1 nanosecond may be round off. Okay, so that means any lesser values are there, like 1 nanosecond is the highest value. Suppose 1 picosecond is there means this value is not considered. Okay, so below values are not considered. Below values means picoseconds or femtoseconds, all these things are not considered, and then it will be rounding off. Okay. And 1 picosecond you are considering, that means accurate timing. Hmm. Accurate timing means exactly it will consider that 1 nanosecond by 1 picosecond. See here 1 nanosecond by 1 nanosecond means before the nanoseconds any values are there, it will not consider that. Suppose 1 nanosecond by 1 picosecond you are considered means actual values, this is 10 20, these values will be considered here. Any doubt in this 1 nanosecond by 1 nanosecond and 1 nanosecond by 1 picosecond? Uh, See here 1 nanosecond by 1 nanosecond you are considered means suppose the precision values will be below the 1 picosecond. So that means nano means 10 to the power of minus 9, right? Pico means 10 to the power of minus 12. So nano is the highest value compared to pico, and micro is the highest value compared to nano, and milli is the highest value compared to micro, right? So then 1 nanosecond highest value is that, lowest value is that picosecond, pico and femto 10 to the power of minus 15. This will be not considered, okay, during 1 nanosecond by 1 nanosecond. Okay, during 1 nanosecond by 1 picosecond, so it is exactly taking that because any value is there that will be considered directly. Suppose 10 nanosecond by 1 picosecond you are considered that. That means each delay should be multiplied by 10. Suppose you are taking, what is the actual delay you are considering? The actual delay hash 5 I have considered that. Okay, that actual delay I will be considered delay number and then time scale. This time scale is 1 nanosecond, right? So 1 nanosecond by 1 picosecond you are considered means no problem. Then 10 nanoseconds is taking, then actual delay it is taking means this delay will be 5, delay number is 5, then time unit is 10, then each and every time 50 nanoseconds it will be considered that. Understood how it is taking that? Actual delay will be multiplied that. Suppose 100 nanosecond by 1 nanosecond you are considered means, so 100 into 5, then 500 nanoseconds it will be taking the delay. Okay, clear? Any doubt in this? So every time the delay value should be multiplied by this time unit scale. Okay, this time unit scale is there, right? Precision value is not there. If you are adding this precision value also, then it will be changing the values. Okay, So suppose 1 nanosecond by 10 picoseconds you are considered means each and every time zero point 0.1 values will be considered there. Or 1 nanosecond by 100 picoseconds you are considering means 0.01 value will consider that. That means whatever the actual delay we have 5 nanoseconds hash 5, this should be multiplied with zero point 0.1, then you will get that 0.5 nanoseconds. And then here 100 picoseconds is there, then 0.01. So 0.01 means actual delay is 5, sorry, delay time unit is 5, then your actual delay is 0.05. In this way it will be considered that. If you are increasing the numerator, that means timescale unit 10 nanoseconds, 100 nanoseconds, 1000 nanoseconds. In this way, you are increasing means this delay will be multiplied with delay time units. That means hash 5 or hash 10 or hash 15, hash 50 you are giving this means this 10 is multiplied with 5, this 10 is multiplied with 10, this 10 is multiplied with 50, or this 100 is multiplied with 5, this 100 is multiplied with 10, this 100 is multiplied with 50. Clear? Any doubt in this? See how compiler directives are will work means source code, whatever the source code we are having, that will be added here. Okay, in the compiler directives contains some directives. Okay, so that will be added. And then the processor time also compiler directives will taking that and expand the macros. We will consider that if you want to include any files, we will consider that and evaluate some conditions like tick if defined, it will be taking that, and then simulation timings also it will be considered. Okay, so this will be disappear while processing the time. Okay, I told you undefined means, so tick undefined, that means remove that. Whatever the condition you are taking means that the macros is not there. That is the tick undefined. Okay. So tick easily you can remember tick defined is that some shortcuts it will be replacing. Okay, width and depth it will be replacing with some shortcut names. And tick include inserting the file. Tick if define compilation conditionals. Okay, some conditionals we will consider that. Tick timescale sets the time, and tick undefined it removes the macros. Okay, so this is what we are explained related to compiler directives. Okay, so see the compiler directives and then um, execute each and everything. Okay, just give me a minute and I will show some examples.